Hey guys, welcome to our Key Concept 1 Target B video. In this target, we are simply looking at solving problems using similarity. So if I know two triangles are similar, I can solve things about those triangles. So let's look at our first example, which is a word problem. Example 1 says, before rock climbing, Darius wants to know how high he will climb. He places a mirror on the ground and walks backward until he can see the top of the cliff in the mirror. What is the height of the cliff? Right? So this problem is assuming these two triangles are similar. But let's see if we can prove that for sure. Remember, we have our three similarity postulates: angle, angle, side, and side, side. Well, if you look here, right, this is a right triangle, and this is a right triangle. So that's one angle they have in common. Right. And then this is telling us here, right, that these two angles are similar. And this is actually using a corollary to the vertical angles theorem, saying vertical angles are congruent. And a corollary is just a theorem that is very similar to the original theorem. So this is pretty much using vertical angles as well to tell us those two angles are similar. Now, those two angles are congruent. Sorry. Now I know these two triangles are similar by angle, angle similarity. Okay? So now I can feel very confident in moving on with this problem. So what I'm going to do is I'm going to set up a proportion to solve this. Okay? So we have the height of our guy here and the height of the cliff over here, and how far he is from the mirror here and how far the mirror is from the cliff. One thing I always do when setting up proportions, I think is easiest, is to start with the variable, right? So I'm going to start with x. And I'm going to compare that, right? That's a height. I'm going to compare it to the height in the other triangle, right? Which is 5.5. He knows his own height. Then, since I started with this triangle, the height of the cliff, I have to start with this triangle on my other proportion, or my other ratio. So I have to start with how far the mirror is from the cliff, since I started with the cliff first. So that's 34. And then I'm comparing that to the distance from the mirror to the man, right, which is 6. Now all I'm doing is solving this proportion. In order to solve proportions, we use the cross product property, right? That's when you multiply on the diagonal. Some people I know also learned it as a butterfly method because it makes a beautiful butterfly. Okay? So this is something that should be a review from either last year as a freshman or even in middle school, right? So we're just going to use the cross product property to solve these proportions. So I have x times 6, which is simply 6x, equals 34 times 5.5. These problems, you can use a calculator. I don't always expect you to do all the large multiplication in your head. So 34 times 5.5 is 187. Now I'm simply solving this, right? 6x is really 6 times x. So in order to solve, I got to do the opposite. I got to divide. My 6's go away. I am left with x, which equals, right, so it's just x. On the other side, 187 divided by 6. I'm going to round so that it's 31.2. A lot of times, we will keep things as fractions in this class. But since this problem started with a decimal, it's probably going to end with a decimal. And then don't forget, this is a real world problem, so I need my unit. So this cliff is 31.2 feet tall. All right, let's go ahead and look at our next example on the next page. Example 2. At 4 p.m., Carl stands next to his house and measures his shadow and the house shadow. Carl's shadow is 8 feet long. The house's shadow is 48 feet long. If Carl is 6 feet tall, how tall is his house? So when you get a problem like this, always start by drawing a picture. So Carl's standing next to his house. Carl's shadow is 8 feet long. So I'm going to draw Carl, and I'm going to draw his shadow. Okay? I'm just going to represent it by a line. This shadow is 8 feet. Then it says the house's shadow is 48 feet long. So here's my house. This is not down to scale. And here's my house's shadow. And that's 48 feet. Then it says Carl is 6 feet tall. How tall is his house? Okay. So Carl is 6. His house, we don't know. That's what we're looking for. That would be our variable, right? And these do really create triangles, right? They create right triangles here. So, just like before, I'm going to set up our proportion. I'm going to start, again, as always, with my variable, which is the height of the house. Right? So you can use h, x, whatever variable you would like. I'm just going to use x. And since I use the height of the house, I'm going to match that with the height of Carl, which is 6. So x over 6 equals. Then, since I started with the house, I have to start with the house on the second ratio as well. The shadow of the house is 48. The shadow of Carl is 8. And now I'm just using my cross product property. 8x equals 6 times 48. And 6 times 48 is 288. And again, this is multiplication, so I'm really just going to divide here to get rid of that 8. On this side, 8 divided by 8 is 1, so I'm left with simply 1x. 288 divided by 8 is 36. Again, don't forget your units. This is a real world problem, so this is 36 feet. Okay, we're going to skip this first part of example 3. I don't like how the equation works out to solve. It's a really hard quadratic. So let's look at B. Okay? So now, when we're solving problems like this, you need to be careful of what sides match with what, right? Sometimes it's easy to look at the angles for help, right? So I have this angle here and that angle here. Those are congruent, so those are corresponding. Then remember we have vertical angles, so those are congruent, okay? So I'm going to start by looking at the triangle where I only have 2 pieces of it, right? Not the third piece. So this 2x, right? It's between the yellow angle and the blue angle. So I want to it's going to correspond with the other triangle between the yellow angle and the blue angle. Okay. Same thing with the 8. This 8 is going to correspond, right? It's the blue angle and the non-colored angle. So blue angle and non-colored angle. X. Okay. So I'm going to start setting up my proportion. I'm going to start with 2x. 2x goes with 9. And since I started with the triangle on the right, I have to start with the triangle on the right for the second one. So it's 8 over x. So then I'm going to cross multiply. I have 2x times x. Well, 2x times x is 2x squared. Right? X times x is x squared. Then I have 8 times 9. And 8 times 9 is 72. Again, for some of this multiplication, if you're struggling with it, just have a calculator, go ahead and use it. So then I'm going to divide 2x squared by 2, right? I want to just get that x by itself. So I'm left with simply 1x squared. And 72 divided by 2 is 36. So I don't have x squared by itself yet. I have to take the square root. So the square root of x squared is x. And the square root of 36 is 6. So x equals 6. All right, let's look at our last example, which has to do with that the angle, the altitude to hypotenuse. So we're solving for x. X is here. So let's look at what our triangles are. X is part of this big triangle. It is also part of this triangle. Okay. And then y is part of that blue triangle, or that blue triangle, as well as this purple triangle. And then remember, this whole side here is 8. So if you look, I have two sides, the leg and the hypotenuse of my one triangle, of that yellow triangle. My blue triangle, I know something about all three sides, and I know two sides of my little triangle here. Try and think about what side is the longer leg and what side is the shorter leg. So I have the longer leg here, and right, and this would be the shorter leg, and you can kind of match that up with all of them. So I'm going to start with the big triangle, and I'm going to start with the blue triangle. Okay, so I'm going to try and start with x. Right. So x here is the long side. So let's look at the blue triangle. So I'm knocking out that part. I do know the long side. It's just 6. Equals. Right, well, what else? I started with that big triangle. What else do I know about the big triangle? Right, I know the hypotenuse. The whole hypotenuse is 8. Looking at just this side. Right, the hypotenuse of this triangle is x. So I have x over 6 and 8 over x. Sometimes it helps if you want to redraw the triangles as well, right? So I had my first triangle, which we'll draw in. Right, so the big triangle, what did I know about it? That's a horrible drawing. Right. I had x on the longer leg and 8 on the hypotenuse. That blue triangle, which I'll draw in blue, right, had y on the shorter leg, x on the longer leg, or no, sorry, x on the hypotenuse, and 6. And then we could also draw our little triangle, which has 2 on the shorter leg and y on the longer leg. Right? So you can draw all your triangles. So we're just looking for x. So I started with x over 6, and then 8 over x. Right? So if you want to break up those triangles, sometimes it helps with seeing what parts are match. So x times x is x squared. Right? And then 6 times 8 is 48. Okay? So I need to take the square root. Right? Well, the square root of x squared is simply x. Let's simplify the square root of 48. Remember, when you're finding square roots, you simply need to find the largest square. Well, 48 is 16, right, which is a perfect square, times 3. So what is the square root of 16? The square root of 16 is 4. Can't take the square root of 3, so it's just that. Right, so x equals 4 square root 3. That's it for tonight. Have a wonderful evening.